So we've already learned about what air pressure is and high and low air pressure systems. Today we're going to take a look at how those are placed on the map using this Isobar map. So we find the pressure systems on the map by connecting these areas of same air pressure. Those lines are called isobars. So anyway, on this map we see isobars that connect areas of the same air pressure. Any point along that isobar has the same air pressure reading. So here's just a little mini example for you. There is a reading of 996, so just 996 is the easy short way to say that for millibars for that number. And every point along that line is supposed to have the same air pressure of 996. It goes by fours, so anywhere in between the 996 and the 1000 has either 997, 998, or 999 until we get to this 1000. So we see that there's lower pressure up here, and as we move outward, there's higher pressure down below. So there's some rules to making these isobar maps. So we're going to look at what those rules are before we get started on actually making one. First, you're going to draw the isobar until it hits a boundary. So notice here, when this 1016 hits the ocean, it stops. It does not go around and connect to this 1016. We hit a boundary. And in our case, it's going to be, let's try to stay inside the US. And if you get a little bit in the ocean, that's fine. But like with this 1016 up here, it hits the ocean. Down here, it hits the ocean, so it stops. It doesn't loop, doesn't connect to make a loop. So you're going to sometimes have these closed circles, especially always at your highest and lowest pressure systems. And then outside of that, you'll probably have another closed circle or more than one. But then eventually you'll get to this point, typically where you've got a big kind of funky U shape here that doesn't connect because it's hitting the boundary of our map. Isobars are curved lines with no sharp corners or kinks. So take a look at these as an example. Smooth curved lines, sometimes there is a little bit of a curved kink in it, but we try to limit those. Again, it's just connecting those areas of the same air pressure reading, so that's why they get to be a little bit goofy looking sometimes, but we try really hard when we're making these to keep the curved lines with no kinks or corners. Isobars never touch or cross each other. They're areas of different measurements, and because of that, they don't cross over each other and they don't touch. They can be really close to each other, like you see in the low pressure system over here. They can be really close together, but they don't ever cross over each other. The 992 down here is always going to be inside the circle for the 996, which will be inside the circle for the 1000 until we get to the 1004 and the 1008. So they are circles within circles, or lines around other lines. They can't ever cross, and they don't touch each other, because in between these two isobars, we have areas of different pressure reading. So this one's really spread out. So we've got 1023, 1022, and 1021 until you get to this 1020. But over here in our low pressure system, they're very close together. So we have different pressure readings that are very close together instead of very spread out. Lines that are next to each other should look alike, so you try and parallel them. And that typically is the case just based on the readings, but not always. So a good example of that is our low pressure system over here, where we've got all these circles that just kind of go around each other. And even down here where it dips a little bit, those lines still kind of look the same. The high pressure system over here, they don't parallel so well. The high pressure system definitely looks different than the 1020. But the 1016 and the 1012 parallel the 1020 pretty nicely as they go along and next to there. So try and make them kind of the same shape. And we don't have all these different weather station readings to go by on our map, so we just have a few. and that means that we're going to connect those particular readings and try and make it smooth curved lines that don't touch or cross and that are pretty parallel to each other. And last, when you're starting one of these maps, pick either the highest number or the lowest number to start with, because you can see here that we have two different pressure systems. So we've got a high pressure system, so I could start with my 1024 over here if I wanted to, and then move on to finding my 1020, 1016, and 1012. Or I could start over here with a low pressure system where it's 992 and then work outwards from there. But you're starting with the highest, which is your high pressure system, or the lowest, which is your low pressure system. We are going to make a map. So you can do this with me through the video if you want to, or you can watch and then make your own. This is in today's folder, and you'll also see a link to this document as we get a little bit further into the directions, because at some point we will have to do this in a Google Doc rather